Hello students, today we solve the exercise 2.3 problems. In first problem, there are two bits, each bit have A, B, C problems. First we solve the first bit A problem. It is given that 1 by 4 of 1 by 4 which is equal to 1 by 4 multiply with 1 by 4 which is equal to, first we multiply the numerators 1 into 1 and then multiply the denominators 4 into 4 which is equal to 1 by 16. Therefore, by 4 of 1 by 4 is equal to 1 by 16. Next we solve the first bit B problem. It is given that 1 by 4 of 3 by 5 which is equal to 1 by 4 multiply with 3 by 5. Then we can write 1 into 3 divided by 4 into 5 which is equal to 1 3 is 3 divided by 4 5 is 20. Therefore, 1 by 4 of 3 by 5 is equal to 3 by 20. Next we solve the first bit C problem. It is given that 1 by 4 of 4 by 3 which is equal to 1 by 4 into 4 by 3 which is equal to 1 into 4 divided by 4 into 3. We can cancel 4 ones are 4 ones are. So which is equal to 1 into 1 divided by 1 into 3 which is equal to 1 by 3. Therefore 1 by 4 of 4 by 3 is equal to 1 by 3. Next we solve second bit A problem. It is given that 1 by 7 of 2 by 9 which is equal to 1 by 7 into 2 by 9 which is equal to 1 into 2 divided by 7 into 9. So 1 into 2 is equal to 2 divided by 7 nines are 63. Therefore, 1 by 7 of 2 by 9 is equal to 2 by 63. Next we solve the second bit B problem. It is given that 1 by 7 of 6 by 5 which is equal to 1 by 7 into 6 by 5 which is equal to 1 into 6 divided by 7 into 5. 1 into 6 is equal to 6. 7 into 5 is equal to 35. And therefore, 1 by 7 of 6 by 5 is equal to 6 by 35. Now we solve second bit C problem. It is given that 1 by 7 of 3 by 10 which is equal to 1 by 7 into 3 by 10 which is equal to 1 into 3 divided by 7 into 10 which is equal to 1 into 3 3 7 tens are 70. Therefore 1 by 7 of 3 by 10 is equal to 3 by 70. First we solve the exercise 2.3 problem 2. In the problem 2, it is given that multiply and reduce to lowest form if possible. There are total 7 bits are given. First we solve the first bit of the given problem. So 2 by 3 into, here 2 by 3 is a mixed fraction, so it can be written as 2 into 3 plus 2 divided by 3 which is equal to 2 by 3 into 2 3 is a 6 plus 2 that is equal to 8 by 3 which is equal to 2 into 8 by 3 into 3 which is equal to 2 8 is 16 and 3 3 is 9. Here 16 by 9 is the improper fraction. We can write it as a mixed fraction. So we divide numerator 16 with the denominator 9. So 9 ones are 9. By subtracting we get 7, which is equal to 1 7 by 9. Therefore 2 by 3 into 2 2 by 3 can be written as 1 7 by 9. Now we can solve the second bit of the second problem. Here 2 by 7 into 7 by 9 is given, which is equal to 2 by 7 into 7 by 9. We can cancel 7, so 7 ones are 7 ones are, which is equal to 2 by 1 into 1 by 9, which is equal to 2 into 1 divided by 1 into 9, which is equal to 2 by 9. Therefore we can write 2 by 7 into 7 by 9 is equal to 2 by 9. Now we solve the third bit of second problem. Here given 3 by 8 into 6 by 4, which can be written as 3 by 8 into 6 by 4. We can cancel 2 2s are 4, 2 3s are 6, which can be written as 3 by 8 into 3 by 2, which is equal to 3 into 3 by 8 into 2, which can be written as 3 3s are 9, 8 2s are 16. Therefore 3 by 8 into 6 by 4 is equal to 9 by 6. Now we solve the fourth bit of the second problem. It here given 9 by 5 into 3 by 5, which is equal to 9 by 5 into 3 by 5. So it can be written as 9 into 3 by 5 into, which is equal to 9 3s are 27 and 5 5s are 25. Here 27 by 25 is the improper fraction, so we can write it as a mixed fraction. So divide numerator 27 with the denominator 25. 25 ones are 25. By subtracting we get to 2. So it can be written as 1 2 by 25. Therefore we can write 9 by 5 into 3 by 5 is equal to 1 2 by 25. Now we solve the fifth bit of the problem 2. It is given that 1 by 3 into 15 by 8. We can write it as 1 by 3 into 15 by 8. Here cancellation possible, so we can cancel 3 ones are 3, 3 5s are 15, which is equal to 1 by 1 into 5 by 8, which is equal to 1 into 5 by 1 into 8. It can be written as 5 by 8. Therefore 1 by 3 into 15 by 8 is equal to 5 by 8. Now we solve the sixth bit of the problem 2. Here given 11 by 2 into 3 by 10, which is equal to 11 by 2 into 3 by 10. Here no cancellation possible, so we can write it as 11 into 3 divided by 2 into 10. 11 3s are 33 divided by 2 10s are 20. Here 33 by 20 is the improper fraction, so we can write it as a mixed fraction. So divide numerator 33 with the denominator 20. So 21 is 20. By subtracting we get a 13. So 13 by 20 can be written as 1. 13 by 20. Therefore 11 by 2 into 3 by 10 is equal to 1. 13 by 20. Now we solve the 7th bit of the problem 2. Here given 4 by 5 into 12 by 7, which can be written as 4 by 5 into 12 by 7. Here no cancellation possible, so it can be written as 4 into 12 divided by 5 into 7, which is equal to 4 12s are 48 divided by 5 7s are 35. Here 48 by 35 is an improper fraction, so we can write as a mixed fraction. So we divide numerator 48 with the denominator 35. 35 ones are 35. By subtracting we get 13, which can be written as 1 13 by 35. Therefore 4 by 5 into 4 by 7 is equal to 1 13 by 35. Now we solve the exercise 2.3 problem 3. In problem 3 it is given that multiply the following fractions. Total 7 bits are given this problem. Now we solve the first bit of the problem 3. Here given 2 by 5 into 5 1 by 4, which can be written as 2 by 5 into 5 into 4 plus 1 divided by 4, which is equal to 2 by 5 into 5 4s are 20 plus 1 is 21 by 4. Here cancellation possible, so we cancel 2 1s are 2, 2 2s are 4, which is equal to 1 by 5 into 21 by 2, which is equal to 1 into 21 by 5 into 2. 1 into 21 by 5 into 2 can be written as 21 by 10. Here 21 by 10 is a improper fraction which can be written as mixed fraction. By dividing numerator 21 with denominator 10, 10 to the 20, by subtract we get 1. So 21 by 10 can be written as 2 1 by 10. Therefore 2 by 5 into 5 1 by 4 can be written as 2 1 by 10. Now we solve the second bit of the problem 3. Here given 6 2 by 5 into 7 by 9, which is equal to 6 into 5 plus 2 divided by 5 into 7 by 9, which is equal to 6 by 30 plus 2 is 32 by 5 into 7 by 9. Multiply 32 with 7. We get 7 2s are 14, 7 3s are 21 plus 1 is 22. So we can write 32 into 7 by 5 into 9 as 224 divided by 5 9s are 45. Here 224 by 45 is a improper fraction. We can convert into mixed fraction by dividing 224 by denominator 45. 45 4s are 180. By subtracting we get 44. So 224 by 45 can be written as 444 by 45. Therefore 6 2 by 5 into 7 by 9 is equal to 444 by 45. Now we solve the third bit of the problem 3. Here given 3 by 2 into 5 1 by 3, which can be written as 3 by 2 into 5 into 3 plus 1 by 3, which is equal to 3 by 2 into 5 3 is 15 plus 1 is 16 by 3. Cancellation possible, so we cancel 3 ones are 3, 3 ones are 3. Here 2 ones are 2 and 2 8s are 16, which is equal to 1 by 1 into 8 by 1, which can be written as 1 into 8 divided by 1 into 1, which is equal to 8 by 1. Here 8 by 1 can be written as 8. Therefore 3 by 2 into 5 1 by 3 is equal to 8. Now we solve the fourth bit of problem 3. Here given 5 by 6 into 2 3 by 7, which can be written as 5 by 6 into 2 into 7 plus 3 by 7, which is equal to 5 by 6 into 2 7s are 14 plus 3 70 by 7, which is equal to 5 into 17 by 6 into 7. So 17 into 17 5 is 5 7s are 35, 5 ones are 5, 5 plus 3 8. So which is equal to 85 by 6 7s are 42. Here 85 by 42 is improper fraction. It can be written as a mixed fraction by dividing numerator 85 with the denominator 42. 42 2s are 84, by subtracting we get 1. Therefore 85 by 42 can be written as 2 1 by 42. Therefore 5 by 6 into 2 3 by 7 can be written as 2 1 by 42. Now we solve the fifth bit of the problem 3. Here 3 2 by 5 into 4 by 7 given, which can be written as 3 into 5 plus 2 divided by 5 into 4 by 7, which is equal to 3 5 is 15 plus 2 is 17, 17 by 5 into 4 by 7, which is equal to 17 into 4 divided by 5 into 7. Here 7 into 4 means 4 7s are 28, 4 ones are 4 and 68, so which is equal to 68 by 5 7s are 35. Here 68 by 35 is improper fraction. It can be converted into mixed fraction by dividing numerator 68 with the denominator 35. 35 ones are 35, by subtracting get 33. So it can be written as 133 by 35. Therefore 3 2 by 5 into 4 by 7 is equal to 133 by 35. Now we solve the sixth bit of problem 3. Here 2 3 by 5 into 3 is given, which can be written as 2 into 5 plus 3 divided by 5 into 3. This can be written as 3 by 1, which is equal to 2 5 is 10 plus 3 13 by 5 into 3 by 1. It can be written as 13 into 3 by 5 into 1. 13 3s are 39 divided by 5 ones are 5. Here 39 by 5 is improper fraction, which can be written as mixed fraction by dividing numerator 39 with denominator 5. 5 7s are 35, by subtracting we get 4. 39 by 5 can be written as 7 4 by 5. Therefore 2 3 by 5 into 3 is equal to 7 4 by 5. Now we solve the seventh bit of the problem 3. Here given 3 is 4 by 7 into 3 by 5, which can be written as 3 into 7 plus 4 divided by 7 into 3 by 5, which is equal to 3 7s are 21 plus 4 25 divided by 7 into 3 by 5. Here cancellation is possible, so we cancel 5 ones are 5, 5s are 25, which is equal to 5 by 7 into 3 by 1, which is equal to 5 into 3 by 7 into 1, which is equal to 5 15 by 7 ones are 7. Here 15 by 7 is improper fraction, which can be written as mixed fraction by dividing numerator 15 with the denominator 7, 7 2s are 14, by subtracting we get 1, which is equal to 2 1 by 7. Therefore 3 4 by 7 into 3 by 5 is equal to 2 1 by 7. Now we solve the exercise 2.3 problem 4. In problem 4 there are 2 bits are given. In each bit we have some fractions, or we have to compare these fractions. To compare these fractions we have to simplify them. First of all we have to write 2 by 7 of 3 by 4 as 2 by 7 into 3 by 4. Here cancellation possible, so we cancel 2 ones are 2, 2 twos are 4, which implies 1 by 7 into 3 by 2, which implies 1 into 3 by 7 into 2, which implies 1 3 is a 3, 7 2 is a 14. Now we simplify the second fraction 3 by 5 of 5 by 8. So it can be written as 3 by 5 into 5 by 8. Yet cancellation possible, so we cancel 5 ones are 5, 5 ones are 5, which implies 3 by 1 into 1 by 8, which implies 3 into 1 by 1 into 8, which implies 3 by 8. In resulting fractions 3 by 14 and 3 by 8, numerators are equal. So we compare the denominator. So denominator 14 is greater than the 8. So we can say the fraction 3 by 14 is less than 3 by 8. That is 2 by 7 of 3 by 4 is less than 3 by 5 of 5 by 8. Now we solve the second bit of problem 4. To compare the given fractions, we have to simplify them. So 1 by 2 of 6 by 7 can be written as 1 by 2 into 6 by 7. Here's cancellation possible, so we can cancel 2 ones are 2, 2 threes are 6, which implies 1 by 1 into 3 by 7, which implies 1 into 3 by 1 into 7, which implies 3 by 7. Next, we have to simplify the 2 by 3 of 3 by 7, which can be written as 2 by 3 into 3 by 7. Here cancellation possible, so we can cancel 3 ones are 3, 3 ones are 3, which implies 2 by 1 into 1 by 7, which implies 2 into 1 by 1 into 7, which implies 2 by 7. In resulting fractions, 3 by 7 and 2 by 7. Denominators are same. So we compare the numerator. So we can say 3 is greater than 2. That is 3 by 7 is greater than 2 by 7. So we can say that 1 by 2 of 6 by 7 greater than 2 by 3 of 3 by 7. Now we solve the exercise 2.3 problem 5. In the problem 5 it is given that Sally plants 4 saplings in a row in her garden. The distance between two adjacent saplings is 3 by 4 meters. Find the distance between the first and last sapling. From the given problem, we can write the number of saplings is equal to 4 and the distance between two adjacent saplings is equal to 3 by 4 meters. To understand better, we draw the 4 saplings. The distance between two adjacent saplings is equal to 3 by 4 meters. And we have to find the distance between the first and the last sapling. So the distance between the first and last sapling can be written as 3 by 4 meters plus 3 by 4 meters plus 3 by 4 meters. Here 3 by 4 is 3 times, so it can be written as 3 times of 3 by 4 meters. Here 3 into 3 by 4 meters can be written as 3 into 3 by 4 meters, which is equal to 9 by 4 meters. Here 9 by 4 is improper fraction. This can be written as a proper fraction by dividing numerator 9 with the denominator 4. 4 2 8. Subtracting we get 1. 9 by 4 can be written as 2 1 by 4 meters. So the distance between first and last sapling can be written as 2 1 by 4 meters. Now we solve exercise 2.3 problem 6. In the problem 6, it is given that Lipika reads a book for 3 by 4 hours every day. She reads entire book in 6 days. You have to find how many hours in all were required by her to read the book. So by given problem, we can write Lipika reads a book in 3 by 4 hours in 1 day. And we have to find the time required by Lipika in 6 days. Therefore, the time required by Lipika to read a book in 6 days is equal to 6 into 3 by 4 hours. And which can be written as 6 into 1 into 4 plus 3 by 4, which is equal to 6 into 1 into 4, 4 plus 3, 7 by 4. Here 6 into 7 by 4 can be written as 6 into 7 by 4. Here cancellation possible, so we cancel 2 2s are 4 and 2 3s are 6, which is equal to 3 into 7 by 2. So 3 7s are 21 divided by 2. Here 21 by 2 is improper fraction. This can be written into mixed fraction by dividing numerator 21 with the denominator 2. 2 tens are 20. By subtracting we get 1. This can be written as 10 1 by 2. So therefore the time required by Libika to read the book in 6 days is equal to 10 1 by 2 hours. Now we solve exercise 2.3 problems. In problem 7, it is given that a car runs 16 kilometers using 1 liter of petrol. We have to find how much distance will it cover using 2 3 by 4 liters of petrol. By given problem, we can write a car runs 16 kilometers distance using 1 liter of petrol. And we have to find distance covered by car using 2 3 by 4 liters of petrol. Therefore, we can write the distance covered by car using 2 3 by 4 liters of petrol is equal to 16 into 2 3 by 4, which is equal to 16 into 2 into 4 plus 3 by 4, which is equal to 16 into 2 4 is 8, 8 plus 3 11, 11 by 4. Now 16 into 11 by 4 can be written as 16 into 11 by 4. We can cancel here. So we can cancel 4 ones are 4, 4 fours are 16. We can write it as 4 into 11 by 1, which can be written as 44 by 1, which is equal to 44. So therefore we can write the distance covered by the car using 2 3 by 4 liters is equal to 44 kilometers. Now we solve exercise 2.3 problem 8. In problem it is given that provide the number in the box such that 2 by 3 times of box is equal to 10 by 30. And second one is given that the simplest form of the number obtained in box is dash. By observing the given problem, if we multiply 2 with 5, we get the numerator 10. Similarly, if we multiply 3 with 10, we get 30. Therefore, the required fraction which is in box is 5 by 10. Next, the simplest form of the number obtained in box is 5 by 10 by cancellation. 5 ones are 5, 5 twos are 2. We get 1 by 2. 1 by 2 is the simplest form of 5 by 10. In the eighth problem B bit, it is given that provide the number in the box such that 3 by 5 into box is equal to 24 by 75. And second one is given that the simplest form of the number obtained in box is dash. By observing the given problem, we can write the numerator 3 into 8 is equal to 24, and by multiplying the denominator 5 with 15, we get a denominator 75. Therefore, 8 by 15 is the required fraction. So the simplest form of the number obtained in the box is 8 by 15. We not have any common factor, so 8 by 15 is the simplest form.